So welcome students. In this topic, let us look at the topic of number of solutions of a quadratic equation. So if you have an equation of the form ax square plus bx plus c is equal to 0, where a not equal to 0, where a is not equal to 0, then this equation is called a quadratic equation. We have seen this in the definition. A, B, C are the coefficients. Ax square plus bx plus c is equal to 0 is called a quadratic equation if the leading coefficient corresponding to x square is not equal to 0. Because if the leading coefficient is equal to 0, it becomes the next shorter equation. If b is also equal to 0, it does not become a quadratic equation, right? So as long as a is not equal to 0, this is called a quadratic equation. And this equation has exactly 2 roots. There's no doubt about it, because the roots are minus b plus or minus root of b square minus 4ac by 2a. So as long as this a is not equal to 0, these roots will always be defined, and you have 2 roots. They can be real and distinct, or real and equal, or imaginary. So as long as a is not equal to 0, this is called a quadratic equation, and it has exactly 2 roots. Now in some questions, you'll be given that you have an equation of the form ax square plus bx plus c is equal to 0. It will not be said that this is a quadratic equation. You'll have an equation of this form if this equation has to have only one solution. It has exactly one solution. Exactly one solution if, what is the condition? It has exactly one solution if this becomes a linear equation, right? So this has exactly one solution if a is equal to 0. So if a is equal to 0, then this equation becomes a linear equation, and it has only one solution. It has no solution if this equation should not have any solution, either in real numbers or in complex numbers. Then what should happen? This also has to be 0. So a equal to b equal to 0 and c not equal to 0. If both a and b are zeros, so this becomes 0. C, if it is not equal to 0, example, if c is equal to 1, so 1 can never be equal to 0. For any value of x, 1 can never be equal to 0, hence the equation will have no solution. Next, what happens if a is equal to 0, b is equal to 0, as well as c is equal to 0? This equation will have infinite number of solutions, because if all the coefficients are zeros, whatever value you put in the place of x, you get 0 is equal to 0. So infinite solutions. Infinite solutions if a is equal to b is equal to c is equal to 0. So an equation of the form ax square plus bx plus c is equal to 0 can have 2 solutions if a is not equal to 0. One solution if a is equal to 0 and b is not equal to 0, and b not equal to 0. Can have no solution if a and b is equal to 0 and c not equal to 0. Can have infinite number of solutions if all the coefficients are equal to 0. So in this case, that is, if a is equal to b is equal to c is equal to 0, we say that the equation becomes an identity. That is, the equation is valid for every value of x. That is called an identity. That is a formula. Something 0 into x square plus 0 into x plus 0 is always equal to 0. So if an equation which looks like a quadratic, I won't say that this is a quadratic equation. Only if a is not equal to 0, then it is called a quadratic equation. So if an equation of this form has to be an identity, then all the coefficients have to be equal to 0. Sometimes you'll be given a question like this. So if this equation has 3 solutions, then what has to happen? So in no case will this equation have 3 solutions. So if A is not equal to 0, it has exactly 2. If A is equal to 0, BC not equal to 0, 1 solution. If AB equal to 0, C not equal to 0, no solution. So if it has to have 3 solutions, the only way is if A is equal to B is equal to C is equal to 0. And in this case, it has infinite solutions. So 3 solutions will always be there if there are infinite solutions. So if you're given that an equation of this form has more than 2 solutions, that means it has to become an identity and all the coefficients have to be equal to zeros. This is a very standard question which will be asked from this. Thank you.